So moving along, I want now to check the projection of the different data sets and so forth. If I go here into my table of contents, I can see here I have NAD83, the states, and then I have also this USGS quads. If I go and right click that and then click on properties and go over to general, under the, not general, sorry, under the source, you can see here that this data set is in North American Datum 1983. What I want to do, like I was saying earlier, is I want to make like values for the center of each of these quads. And how I'm going to do that is I'm going to do that in the attribute table. So if I go here, right click, open up the attribute table, I can see here that each one of the quads has this quad name and then different informations about it. I'm going to close this editor toolbar. What I'm going to do now is I'm going to add in a field, a new field called double, and what I want to call it is NAD83. Okay, and then I want to add another one called NAD83 as a double. NAD83. So, like before, like we've used many times, the field calculator, there's another option here called calculate geometry. And if I go into here and I say calculate geometry, it's going to give me this warning message about doing outside of the edit session. That's okay, it just means that this can't be undone. If I hit yes, and you see here I can choose now that I wanted to do the x coordinate the x coordinate of the centroid, and that's going to give me the x point in the middle of that polygon, of that little square that we had zoomed in earlier. And I want to give that in decimal degrees. So I'm going to go ahead and hit OK, and you can see it's using North American Datum 1983. So I hit OK, and it does the calculation, and you can see the calculations going through. And then you'll see here now the values, -95, so forth. So basically it's taking the quad here and it's giving me the x coordinate for right here. And you can see here at the bottom corner, you can see the x coordinates. I'm going to do that also for the y. So right click again, calculate geometry, yes. And then here I can choose the y coordinate of the centroid, again in decimal degrees, NAD83. That's good, and I hit OK, and then that calculation is going to go through. Okay, so now that we've done that, I want to now take this shapefile here that we have currently in NAD83 and change it to NAD27. And the way we're going to do that is by going into the Arc toolbox and using the Project tool. And be careful not to use the Define Projection tool. Again, Define Projection tool is just to overwrite the projection. Project tools actually to do a projection, to reproject it, to convert it into a different projection. So you can see here, don't use Define Projection. Go here into Feature, and then you can see here, Project. Features will be for vectors, so these are for shapefiles, geodatabases, blah, blah, blah. And then rasters here will be for like TIFFs and so forth. So anyways, I'm going to click on Project. You'll see here the toolbox comes up, and it's always nice to click on tool help, the show the help here, and you can see on the side, and you can see we have this tool, this shapefile here that we're wanting to project, and then after it does a projection on it, and you'll get an output. So if I go here and I click on USGS 24Q and open that up, I want to choose where it's going to be exported to, so I'm going to click here, open up this folder, and just go ahead and go to my connected folder, go into my data, and name it USGS 24Q NAD27. Name it something that is obvious what's happened here. And then here now I can choose my output coordinate system. So if I click on here on this select spatial reference property, I can see that I can now go in here and choose my output coordinate system. So if I go here now and I select and I go to projected, not to projected, geographic coordinate systems, North America, I can go here and I can find NAD27. I hit add, and you see now it's using the NAD27 information instead. I hit OK, and then after I have here now choices to do which projection system to use. And here you see there's Alaska and Puerto Rico, so forth. We want NADCON. That's the one we're doing, NAD27 NADCON. If I click on here, it's going to add that as the projection transformation to use. And I'm going to go ahead and hit OK now. When you hit OK, you'll see here in the corner your toolbox starting to work, saying project. One thing that you also always do is go to geoprocessing and look at the results window here, and you'll see here under current session it will show you all the different tools and toolboxes and give you processes. You'll see here now the projection has been done, and now I can go and turn off this and look here and open up the attribute table on here, and you can see that it still has the X and the Y from the NAD83 in there, but if I open up the properties and I look here in the coordinate system, I can see that this is now in 1927. So go ahead and do the same thing with adding the two fields, two double fields. So I'm going to click on add field, choose double, and then I'm going to choose X NAD27, hit OK, and do another one called X, so add a field, and call, Y NAD27, and also make sure that's a double, and hit OK. And then I'm going to use that same calculate geometry that we did before to calculate the centers for this. So I'm going to right click, calculate geometry for XNAD27, yes, and then here I see I'm using the coordinate system NAD27, X coordinate, that's all good. So I hit OK, and that's going to do the calculations for that. Now do the same thing for the Y, so right click the Y, calculate geometry, yes, change this to Y coordinate system, make sure this is NAD27, and then hit OK, decimal degrees again, perfect. So that calculation goes through, and now if you look closely, you can see there's actually a difference between the Y and the X's. So you see your X here, all the numbers are about the same up until the 1000th decimal place. You have 715 here, and then over here you have 226. So there is a difference between the two numbers, and that's good. So now what I want to do is I want to add in another field, again a double field, add field, and this time I want to call it X, the difference between the longitudes and the latitudes. So I'm going to call this D long sec, because I'm going to do this in seconds by dividing by 3,600. So double. Then I'm going to do the same thing here, and I'm going to say add a field, double D lat sec. So then I can use that formula that's on the worksheet, which is just basically subtracting the two values and then divided by 3,600, which is the number of seconds that are in a degree of longitude or latitude. So if I click here and I say field calculator this time, I can choose here that I want to say that D long sec is going to equal to the X NAD83 minus the Y, minus the X NAD27, and I want to put that whole thing into parentheses, so it will calculate it first, and then multiply that by 3,600. I'm going to hit OK, and then that calculation will take place. propagating this with the differences in seconds of the datum shift. Now do the same thing with the latitude, field calculator, and this time instead of X NAD83 and X NAD27, I'm going to do Y NAD83 and Y NAD27 and hit OK. Same thing happened. One other thing that I'm going to do for the video that's not on the lab though, I want to do the full distance. So if I go in here and I say add a field, and I choose here another double and I call it just difference in seconds, I can use the Pythagorean theorem, which basically says that if you take the squares of the sides, the hypotenuse will equal also to the square. And pretty much here what we're going to do is that you can pretend that there's 2 points here. We're going to be able to take the x differences and the y's differences, square them, and that's going to equal to the total difference squared. So we just take the square root of that. So we're going to plug that formula into here too for the change, the full change. So I'm going to say field calculator, and what I want to do now is I want to take this, I want to square the degrees of the difference in longitude, and I want to add it to the square of the difference of latitude, and I want to take this whole thing and I want to square root it, which I can do by adding parentheses to the whole thing and doing the caret to 0.5. That's going to raise it to the power half a power, which is the same as doing square root. So let's see if my code is good. I hit OK. It's thinking, and I had a failure. So maybe it didn't like my 0.5. I can investigate what's happening here with the error messages. If I see here general error calculating, they had invalid argument with the square. So what we can do is if we double click this, it will bring this back up and we can see here what happened, and maybe didn't like the square. So instead of doing the squaring, what we can do is completely change the way we did it by going to field calculator. Let's take off square, and let's try doing it by taking this to the 2 times this one caret 2, and that's going to square both of them, and then the whole thing to the caret 0.5, and let's see if this gives us better luck. So let's hit OK. It's thinking, and this time the calculating record is going through, which is good. So basically this is kind of like how things always tend to happen. ArcMap, you have these things, tools, and you get failures, and you go here to your results and you see your messages and you try to decrypt what that means, and then you go back and you try again. And now you can see here from this formula it worked, and the formula basically was taking the difference of longitude in seconds, squaring it, multiplying it by the difference in latitude, seconds, squaring it, and then raising it all to the half power, which is the equivalent of doing the square root. We could have also looked here and tried to do it through here, but obviously I was just having a problem with these functions. So good. So now we have actually calculated the differences in longitude and latitude, and also its total difference. And now in the next part we're going to take that and do some interpolations and rasterification of that.